Students, in last classes, we have studied about the discriminant of a quadratic equation. So, if ax square plus bx plus c is equal to 0 is the quadratic equation, then its discriminant is b square minus 4ac, and the discriminant tells you about the nature of the roots. So if b square minus 4ac is greater than 0, then the roots of the quadratic equation are real and distinct. If b square minus 4ac is equal to 0, then the quadratic equation will have a single root. And finally, if b square minus 4ac is less than 0, then the quadratic equation will have no real root. So, let us solve some problems on these discriminant. So, come to the first question here. The quadratic equation x square plus 2kx plus 25 equal to 0 has only one root. Find the possible values of k. So, in such cases, first you compare the given quadratic equation with ax square plus bx plus c equal to 0. So, in this case, a, the coefficient of x square is 1. b, the coefficient of x, and that is 2k here. So, b is 2k and c is the constant 25. Now, it is given that the quadratic has only one root. The quadratic has only one root, and that will mean the discriminant b square minus 4ac should be equal to 0. So put these values: b square, that is 2k the whole square, minus 4, a is 1 and c is 25, equal to 0, which gives 4k square minus 100 equal to 0, or that is 4k square is 100, or which means k square is 25. So now take the square root, and when you take the square root, keep it in mind that square root can be positive or negative. So k can be plus or minus 5, and hence possible values of k are either 5 or negative 5. So let us come to question number 2 here. So take down this question now. Find the range. Find the range of values of k for which x square plus 20x plus k equal to 0 has no real roots. So now, if the quadratic equation ax square plus bx plus c is equal to 0 has no real roots, then what will be the condition on the discriminant? The discriminant b square minus 4ac should be negative, less than 0. If the quadratic has no real roots, its discriminant is negative. So, compare the given quadratic equation with ax square plus bx plus c equal to 0. That means a should be equal to 1, b should be 20, and c should be k. Put these values in the discriminant. So that means 20 square minus 4 into 1 into k is less than 0. So which means 400 minus 4k should be less than 0. This is an inequality. So how will you solve it? Just like the equations. So 400 get minus 4k on the other side, that is 4k, which I can also write it as 4k is greater than 400. So if I divide by 4, k is greater than 100, and which means for any value of k that is greater than 100, the quadratic equation will have no real roots. So if k is greater than 100, the quadratic equation has no real roots. So keep it in mind that when it is said in the problem that the quadratic equation has no real root, that means the discriminant b square minus 4ac should be less than 0. Now come to another type of question here. Show that fx is equal to 4x square plus k plus 8x plus k, where k is a real constant has two distinct real roots, has two distinct real roots for all values of k, for all values of k. Now don't get confused by k is a real constant. It means k is any real number, and we have to show that this quadratic equation has always two real distinct roots for any value of k. So again here, first write down the values of a, b, c. So a is 4, b is k plus 8, and c is k. A is the x square coefficient 4, b is the x coefficient k plus 8, and c is the constant k. Now keep it in mind that you have to show that, you have to prove that the quadratic equation has two distinct real roots. So don't directly take b square minus 4ac is greater than 0. We have to show that b square minus 4ac is greater than 0. So just take b square minus 4ac, which is k plus 8 the whole square minus 4 into a is 4 and c is k. Expand k plus 8 the whole square, that is k square, plus 2 into k into 8, that is 16k, plus 8 square, that is 64, and minus 4 into k, that is again 16k. So as you can see here, 16k gets cancelled. So k square plus 64. Now k is a real number, so k square can be greater than or equal to 0. So if I add 64 to a quantity or a number which is greater than or equal to 0, I will get a number which is always greater than 0. And hence that means the discriminant b square minus 4ac for this quadratic equation is always greater than 0, and which means the quadratic equation has two distinct roots for all values of k. Okay, so whenever such problem comes that you have to show that the quadratic equation has always two distinct roots, directly don't start with b square minus 4ac is greater than 0. Take b square minus 4ac and show that b square minus 4ac is greater than 0. Okay, because you have to prove that the quadratic equation has two distinct roots.